Okay, so for 3-7 equations of lines, now you may be wondering, why did we jump from 3-4 to 3-7? Well, we like to save 3-5 for the end of topic 3, and then we'd skip topic or 3-6. So yes, 3-7 comes after 3-4, so don't be afraid of that. You don't have to leave space in your journal. Just go 3-4, 3-7, write your notes, do your work, do all that stuff, okay? So for equations of lines, this is going to feel like a bit of refresher from Algebra 1. And I also have a poster about this posted under modules, topic 3 posters. And so if you scroll down to the bottom, you will see a poster that has a lot of this information on it, along with all my other posters. So equations of lines. Slope equals rise over run. We remember that. Or you guys may have heard of it said as the change in y over the change in x. Okay. And it's usually as m when we're talking about slope-intercept form, or when we're talking about equations of lines. We usually write it as m. So that's a very important thing to understand here about what slope is. And I'm going to look at some example problems here in a moment about how to find slope. So I'm not going to write any on here, but we're going to look at the textbook, okay? Y'all may have heard of Slope Man before. If you haven't, that's okay. Slope Man is just a really funny, sad-looking man where we can see this is positive slope, this is negative slope, this is undefined slope, and this is zero slope. So horizontal is 0, vertical is undefined, positive is rising to the right, negative is rising to the left. So those are, that's slope. And then we got forms of linear equations, okay? So you are probably very, very common with slope-intercept form, right? Y equals mx plus b, where m is the slope and b is the y-intercept. We are comfortable with that. Now, one that's much more helpful in geometry is point-slope form, okay? So we have y minus y1 equals mx minus x1 in parentheses. Now, something to keep in mind here. If you're like, I don't know how to fill these in, I'd like to stay consistent with this. All the things in black stay the same when you're making a linear equation, or when you're making equations, or when you're doing stuff in my class. All the stuff in black stays the same. You fill in all the stuff in color. So in this case, they would give you a slope, give you an intercept, or you would have to find it yourself. You could find the slope, find the y-intercept, and plug those in where the colors are. And then, same thing here. It would give you a point with an x1 and a y1. Remember, always x comma y. And it would have, we would plug in y minus y1. We'd plug in a number there. We wouldn't plug in a number here. That's in black. Okay. We'd have to subtract and then mx minus x1. Okay. So that's very important. Now, before I get to the exam problems, one thing I do want to say is we also work in the reverse. So if I said our slope was 2 and our point was 1, negative 3. Now, one thing I want to point out is when we plug this in, y minus our y1 equals slope, parentheses, x minus our x1. Now you guys observe here, it's y minus negative 3. So this would actually turn into y plus, I don't know why I was about to put a parenthesis there, y plus 3 equals 2x minus 1. So now the reverse of that, we want to be careful. So in this case, we were given this stuff, and we gave this. This is our answer. So this was our given, okay? And this was our answer. We don't have to do anything with that answer. If it asks you to write an equation of a line, this is our equation of a line, which is what a lot of these questions will ask for. And then you're like, what do I do with this? That's it. That's all you have to do. You could change it to y equals mx plus b if you wanted to, but you do not have to. So that's a really important thing to note. Now, let's say we were given something different. What if we were given y equals y plus 3 equals 2/3 x minus Oh, plus 3 was already there. Let me change this up a bit. Sorry, y'all. Minus 4, and then I want plus 1. Okay? So let's say we were given that. Y minus 4 equals 2/3 x plus 1. And it told you to take out a slope and a point. Well, slope is really easy to find. Our slope is 2/3. Okay? And then I should have been doing this in blue. That's our slope. And then our point comes from these two things. Now, the way I want you to think about this is we kind of have to reverse the signs. Because our formula is y minus y1, this y coordinate is not -4. It's just the 4. Okay, so our y, remember it goes x comma y. So our y coordinate is just 4. But that makes our x coordinate not just 1, because we have to think of this as x minus -1, because in the formula it's x minus. Minus is in black. That doesn't go with the x one. We have to separate those two and see that our x coordinate is -1. So that's a very important thing to point out. And this one is also very important. If given 2 points to make an equation, find the slope. So we do y2 minus y1, x2 minus x1. So if it gives you just 2 points, it doesn't give you a slope and a y-intercept, it doesn't give you a point and a slope, it just gives you 2 points. Well, if we have 2 points, we can find the slope, just like up here. y2 minus y1, x2 minus x1. We can find the slope, then use point-slope formula. It doesn't matter which point you pick for the point in here. It could be the first point or the second point. It doesn't matter. This does not apply. Let me pause this. Okay, so I fixed that. Textbook page 127, all even numbers, problems 1 through 22. So that's just the even numbers. That's if you're doing the textbook problems. If you're doing Math Excel or a different assignment, that's totally fine. I just had to correct that on there. Now I do want to talk about the example problems. So first of all, it says example problems on page 124. So this is what page I'm on. And then we can see deriving the slope formula, but we're just going to be talking about how to find the slope. So on this problem, let me zoom this in a bit more. Okay, on this problem, for slope of line B, so we take B, we can see this point and this point are on B. Now it doesn't matter which ones are x1 or x2 or y1 or y2, as long as we stay consistent. So if this is our 1, this is our 2, stay consistent. If this is our 1, this is our 2, stay consistent. So you can see they picked this is our 2, and so they made sure those two were both in front, y over x, and then down here as well. You can also count, so if you're like, I count, rise over run, that's totally fine as well. Just notice that this is a negative slope, okay? And then for slope of line D, if we look back at slope man, we could see that that's going to be undefined because it's a vertical line, okay? Now for a little refresher on how to graph lines, this is very important for how to graph lines. Remember, we want it in slope-intercept form to graph it. So if it's in point-slope form, like this one was, we could switch it into, actually I'm going to switch this one, into y equals mx plus b. So I'm going to distribute the 2. So I have y plus 3 equals 2x minus 2. And then I'm going to subtract 3 on both sides. And then I have my slope-intercept form. So that's what form I wanted in before I start trying to graph it, okay? So I take my y-intercept, I put that on the graph first, and then it's rise over run, right? Up 2 over 3. So that's very important to note. Now, if this is a whole number here, like how this one was just 2, remember, any number is over 1, okay? So that's rise 2, run 1. It's very important to know. So that is how you slope, or how you graph a line, and this is showing the exact same thing, just in a different example. So if you want to pause and look at that, recommend it. Looking at another example problem, writing an equation of a line. So this is what I was talking about, using these two to write equations. We fill in the stuff that's in color and we leave the stuff in black. So if it gives us the slope and y-intercept, we want to use slope-intercept form. We replace, substitute, and that's our answer. You don't have to do anything with this. So when you get to these questions that say use the information to write an equation of our line, the answer is just that, okay? Or just that. You don't have to do anything more than that. Same thing here. If it gives you a point and a slope, we plug in all the information, and that's our answer. We do nothing more than that. Now, the last two are also very important. With this one being, what if it gives you 2 points? It doesn't give you a slope and a point, or a slope and a y-intercept. Well, we first have to start by finding the slope. So we do y2 minus y1, x2 minus x1, and then we find our slope. Now, it doesn't matter which point you use. I could use this point or this point, okay? And then I plug that into the equation. And this is my answer. I cannot repeat that enough. Our answer is the equation, okay? So that's very important. And this last one, this is especially important for how to write vertical and horizontal lines, or especially if you ever see x equals or y equals. It's important that you do this correctly. So this line right here, okay, this horizontal line, that is the equation y. See how it's touching the y-axis? So it's y equals 4. And we can see that our y value is 4 here. So this horizontal line is at y equals 4. There's also going to be a poster up on the posters page. It's in the top right corner of my classroom that shows you how to graph horizontal and vertical lines. And so for horizontal lines, we can graph, we say y equals, we go to the y spot, and we graph a horizontal line. For vertical lines, okay, we go to where x equals 2, we go to that spot, and then draw a vertical line. That's very important. So look at the posters in that section as well. And like I said, it's all the even problems, 1 through 22. So this page, just all the even problems. If you have any questions, please reach out. And that is what section 3-7, equations of lines, is all about.